Hey there, and welcome. Today, we are diving into something really cool, a puzzle right at the core of how science actually works. And it's a twist that's going to flip everything you think you know about proof right on its head.
I mean, think about it, right? You hear it all the time. Science has proven this or that. But what if I told you that's not really true? That logically speaking, science can never 100% prove a big theory is correct. Sounds weird, I know. So let's dig in and unravel this thing.
All right, so first up, we're going to tackle what I'm calling the myth of scientific proof. And we'll use a super simple case to get at a really big, profound idea about what it even means to know something.
Okay, so to get this, we need to know what we're talking about. The thing at the center of all this is what's called a universal statement. It's basically a huge claim, right? A theory that says something is true for everything, everywhere, for all time. And for our little investigation, we're going to use the classic example. All swans are white.
So, you've got your theory. All swans are white. Simple enough. Now, you put on your scientist hat and you're thinking, okay, I gotta prove this. And believe me, this is where the long search begins.
So how would you do it? How would you try to prove that all swans are white? I mean, the obvious answer is you go find swans, right? You gotta collect evidence, find observations that back up your idea.
And so you do. You start the search. You're out there observing, taking notes, and hey, look at that. You find 1,000 white swans. 1,000. Your theory is looking solid. That's a ton of evidence piling up.
But you're not just messing around. You're a serious scientist. You spend years on this, you've got colleagues all over the globe sending you data, and that number just shoots up. Now you've got records for 100,000 white swans. Wow. At this point, you've got to be thinking, okay, this is it. We're about to prove this thing.
Let's just get crazy with it. A million white swans. That is a mountain of evidence. It's overwhelming. But here's the catch. Here's the logical trap. Are you really truly 100% certain? Can you guarantee, without a shadow of a doubt, that swan number 1,000,001 is also going to be white?
And the answer, maybe surprisingly, is no. You can't. This whole process, just stacking up positive examples, that's called inductive reasoning. And here's the kicker. It's not logically foolproof. You just can't make the jump from a limited number of sightings, even a million of them, to an infinite universal rule.
This is the core of the problem. A universal statement like all swans are white doesn't just mean all the swans you can see. It means every swan that has ever lived, every swan that will ever live on this planet or any other. So to prove it, you'd have to check every single one, past, present, and future. And yeah, that's just impossible.
Okay, so trying to prove something true is looking like a dead end. It's impossible. But what if we flip the problem around? This is where things get really interesting.
Picture this. You're out on an expedition, maybe in Australia, and then you see it. Just one. A single, undeniable black swan. After all that work, after 1,000,000 white swan sightings, you're now face to face with one piece of evidence that screams, you're wrong.
And in that single moment, boom, the game is over. Your beautiful theory, all swans are white, isn't just in trouble. It's not just questionable now. It is completely, 100% logically obliterated. It has been proven false. Done. So what just happened? How is it possible that one little black swan is more powerful than 1,000,000 white ones? Well, it's all about this really elegant idea, the logic of asymmetry. See, this is a totally different kind of logic. It's not that flimsy induction we talked about. This is deduction, and it is rock solid. Think about it. 1. Your theory says only white swans can exist. 2. You observe a black swan. 3. Therefore, your theory has to be wrong. It's a perfect, inescapable conclusion.
And that's the whole ballgame right there. Trying to verify something, that's an endless mission that never gives you a certain answer. But trying to falsify something, that can be done with a single observation and the answer is definite. And that difference, that lopsided power, that is the asymmetry that drives science.
Okay, cool. A neat logic trick. But so what? Why does any of this matter in the real world? How does this little idea actually power all of scientific progress? Let me give you one more example that really nails this down. Let's say you make a huge claim. There is absolutely no gold anywhere in the entire continent of Australia.
Okay? How on earth would you prove that's true?
To prove it's true, you'd literally have to check every cubic inch of an entire continent. Every rock, every grain of sand. I mean, come on, that's impossible. But to prove it's false, all you need is one guy with a gold pan to find one tiny little nugget. And just like that, your entire theory is toast.
So here's the big idea, the main takeaway from all of this. Science makes progress not by proving theories right, but by aggressively trying to prove them wrong. A great scientific theory isn't great because it's proven true. It's great because it's falsifiable. It sticks its neck out and makes a bold claim that we can actually go out and test and maybe, just maybe, chop its head off. That vulnerability, that's what makes it so powerful.
And this quote just sums it up perfectly. Yeah, we can find tons of evidence that supports a theory, we can build up a lot of confidence in it, but we can never ever say it's 100% verified. Our best theories are always living on the edge, just one new discovery away from being completely upended.
So I'll leave you with this to think about. What proven fact that you absolutely believe in right now is just one little discovery, one black swan, away from being totally wrong? Kind of makes you think, doesn't it? Thanks for listening.